Hello everyone. In this video we are going to look at the second part of our compound angle formula series. Okay, so let's see what do we have here. We need to prove that sine alpha minus beta equals sine alpha cos beta minus cos alpha sine beta, right? Now, similarly, we have cosine of alpha minus beta as cos alpha cos beta plus sine alpha sine beta. From the previous video, if you remember, what do we know? All we know is that these are the trigonometric ratios, and trigonometric ratios are same irrespective of the triangles that they reside in. What was the method that we used last time to prove the compound angle theorem? We use the method called mount and pack. We are going to use similar method in this video. Okay, in this video I am going to restrict myself to proving sine of alpha minus beta. In the next video we will take care of cos of alpha minus beta. Okay, now remember that in this video we are going to prove the identity exclusively for acute angles. Okay, right. Now let's see how the construction goes. First of all, we are going to draw a right triangle ABC, right? Now the acute angle here is beta. On top of this, we are going to keep our required triangle with acute angle alpha minus beta. Alright, so that would be ACD. See, we have ACD. This angle is right angle, and we have this as alpha minus beta. Now, once we have done this part, if you remember, is called mounting. Beta plus alpha minus beta is nothing but alpha. Now what we are going to do is going to pack. We are going to pack this whole thing in two other set of triangles. Now one is AFD, where this angle would be alpha. See, why? This angle is beta, this angle is alpha minus beta, the sum of it is alpha. This angle FAB is 90 degrees, so the remaining angle FAD would be 90 degrees minus alpha. And since AFD, this triangle is also right triangle, we have the other one, angle FDA, as alpha. Now look at this triangle CED. Okay, now since we have this angle as beta, this angle as 90 degrees minus beta, this angle would be beta. Why? Because on one side of a line, the sum of all angles will be 180 degrees. This is 90 degrees, this is 90 degrees minus beta, which means this angle is beta. So in exam, if someone asks you for construction, you are going to first draw this triangle ABC. Draw the right triangle ABC as shown with acute angle beta. That's the first step you are going to do. The second step is draw the right triangle ADC on top of triangle ABC with acute angle alpha minus beta. So first you draw ABC, and on top of that you are going to mount ACD, this triangle. Okay, with the acute angle alpha minus beta. Now how are you going to mount? You are going to mount in such a way that this angle beta and this angle alpha minus beta share a common point, that is A. Okay, now the third thing you are going to do, extend this line BC. Okay, and draw a line parallel to BC originating from A. We are going to draw a line parallel to BC originating from A. That would be our AF. Okay. Now draw a line parallel to AB. This line from D. So there should be a line parallel to AB which should pass through this point D. Okay. So that is our line EF. Okay. Now see here. AB is parallel to EF. Okay. And B, this angle B is 90 degrees and we are extending it to touch EF at E. Okay. What this means is that if you consider the parallel lines AB and EF and BE as our transversal, okay, this angle E is also 90 degrees, right? Now we have another right triangle CED. Okay, now we have this angle beta. Fine. Okay. Now what we have observed is that we have two triangles AFD and we have triangle CDE. Okay, and if you observe, AF is parallel to BE, EF is parallel to AB. This is by construction. Okay, this is by construction, and we have four right angles in this quadrilateral. Okay, now which is the quadrilateral that has four sides? Obviously all quadrilateral has four sides where opposite sides are parallel. Okay, opposite sides are parallel. Okay, and each angle is 90 degrees. See, in a quadrilateral, if opposite sides are parallel, it becomes a rhombus. But if each angle is 90 degrees, that means this will be a rectangle. Okay, if this is a rectangle, then by construction, okay, we have AB equals EF. AB equals EF, and similarly AF equals BE. That's what we have. See, we have AB equals EF and AF equals BE. This is very important for our proof to continue. Again, just a small reminder that we are proving this only for acute angles in this video. Maybe if I get time, I'll go to obtuse angles. Okay, the identity remains the same. Only thing is that currently we are proving it for acute angles. In future we'll see how to do for obtuse angles. Okay, yeah. Now look at this. What do we have in this particular rectangle? We have four triangles: ABC, ADC, CED and AFD. We have four triangles. So first let us write off all the known entities. Okay, we have sine of alpha. From AFD we have AF. Okay, this is alpha. AF by hypotenuse AD. Okay, cos alpha we have FD by AD. Okay, same triangle AFD. Okay, now sine beta we have, let's take this triangle ABC. Okay, in that we have sine beta, opposite side BC by hypotenuse AC. Okay, and if we take in the triangle CDE, the small triangle, this angle is also beta, right? We have determined that. Okay, now in that triangle CDE, what is sine of beta? Sorry, DE, opposite side by CD, hypotenuse, DE by CD. Now let's take cos beta. Cos beta, in this triangle we have AB by AC, and in this triangle CDE we have CE by CD. Okay, I hope you all remember Pythagoras theorem. Okay, what is Pythagoras theorem? Quick recap. Okay, in any right triangle ABC where angle B is 90 degrees, we have AB squared plus BC squared is AC squared. Remember this, we are going to come to it later. Okay, now what do we need to prove? We need to prove that sine of alpha minus beta equals sine alpha cos beta minus cos alpha sin beta. For cos terms, we'll come to it later, but currently just remember this. Now, what all we know, we are going to put it in one neat little box. Okay, here. Now, let's look at what all we got from the previous slides. Okay, we have AB equals EF and AF equals BE. Okay, that we have put it in a neat little box, and we have the like equations from the previous slide. So look at this, from 1, 5, 2, 3, from equation 1, equation number 5, equation number 2 and equation number 3, this one, we are going to substitute sin alpha cos beta minus cos alpha sin beta. Okay, from equation number 1 we have sin alpha as AF by AD, cos beta from equation number 5 we have it as AB by AC, and from equation number 2 we have cos alpha as FD by AD. Okay, and from equation number 3 we have sin beta as BC by AC. Okay, now remember I am going to substitute AF as BE because we have it here. Okay, neat little substitution. Okay, and similarly AB equals EF, that I'm going to substitute here. Okay, why? Now you should ask me why. Why? Because here I have FD into BC. What is FD? FD is this guy, and BC is this guy. There is no direct relation, right? See, AFD in this triangle only you will have FD, and in ABC in this triangle only you will have BC. Okay, if I keep these two entities separately, I won't get what I require, right? I need to find a commonality, like somewhere I need to bring them together. Okay, hence what I have observed is that if I take these entities AF and AB to be their counterparts, now what I can do is that I can expand upon it. Now see, BE is nothing but BC plus CE, right? Okay, BC plus CE. Okay, now similarly EF is nothing but ED plus DF, ED plus DF here. Okay, now since I have this, I'm going to expand it. I'm going to expand it in this way: BC into ED, EC into ED, BC into DF, and EC into DF. And this one, FD into BC, we are writing. The next thing is that we observe that this FD into BC and this FD into BC can be cancelled. So I am cancelling them off. What do we have left? BC into ED, EC into ED, and EC into DF. BC into ED, EC into ED, and EC into DF. Now you have BC and EC. If I take ED common, and can you add BC and EC? Let's see. BC and EC. Okay, you can add them up, right? That will give us BE. So that is one way you can do about it, combining these two. Or you can go in a different manner. What I have done here is that I have taken EC common from these two, EC, and see what we are getting here is ED and DF, ED and DF, ED and DF. That will give me EF. EF. Okay, cool so far? Okay, now we have this BC into ED plus EC into EF by AC into AD. Remember that from the previous steps? We have this common denominator, AC into AD, right? Now what can I do with this? Well, pretty much nothing, right? I can do one substitution again. This EF is there, right? This EF is nothing but AB. I'm going to take AB. Once I do that, I realize that I have some trigonometric ratios creeping in. See, BC by AC, AB by AC, here we have. Okay. The problem is ED plus EC. What is ED plus EC? Nothing. ED is here, EC is here. You can't add those terms, or at least meaningfully. Okay. So what I'm going to do is that I'm going to substitute these ratios with corresponding to this triangle. See, what do we have here from equation 3 and equation 4? BC by AC is nothing but DE by CD, and AB by AC is nothing but CE by CD, and the odd terms here we have are ED, EC and AD, right? Because AC, BC by AC, you can derive some meaning out of it. We have AB by AC, you can derive some meaning out of it. But what does ED and EC have to do anything with this? Nothing, right? So what I'm going to do is that I'm going to substitute BC by AC by DE by CD. Okay, DE by CD. And similarly, this angle AB by AC, I'm going to substitute it as CE by CD, CE by CD. Okay, here we have it. Now what does this bring us? This brings us to something magnificent. See, we have ED into ED, ED squared, EC into EC, EC squared, ED squared plus EC squared in a right triangle is CD squared, right? We have CD squared. Now we can cancel this CD, and we will be left with one CD. Now CD by AD, observe this carefully. We have CD by AD, and if you take this triangle ADC, CD by AD is nothing but sine of alpha minus beta, right? Which means our original expression sine alpha cos beta minus cos alpha sine beta has led us to sine of alpha minus beta. Again, remember, this is exclusively for acute angles alpha and beta. Okay, LHS equals RHS, hence proved. Okay, now take care, see you in the next video. Bye bye.